Welcome to a module that will focus on malicious programs. As we've discovered in the previous module, a session is the last security boundary that Windows provides. Everything that ranks lower, all processes that you run in the context of a session, you do at your own risk. In this module, I'd like to take a look at the threats related to the fact that a process might have unrestricted access to other processes in a session. If the session is run as an administrator, a launched process may have access to the entire operating system. The first category of malicious software I'd like to analyze are Trojan horses. The term Trojan horse is often misapplied. The press and media are the biggest culprits here. It's often mentioned in the news that a Trojan horse was detected or made it possible for intruders to attack a system or connect to a victim's computer. Actually, to be precise, it's the so-called backdoor that enables an attacker to obtain access to a targeted computer. The role of a Trojan horse is to conceal itself as another program. It's a user-targeted attack. And even if you remember to update your defense mechanisms, have a top-shelf antivirus and the most expensive firewall, this doesn't matter with Trojans. If you launch a Trojan horse, your operating system will allow it to execute. It's an example of a social engineering attack. And since there are automated tools for generating Trojans on the internet, this attack ranks among the most dangerous. We'll use here a rather old piece of software created in 2003 or 2004 by Tatya, a Turk who went on to sell the tool online. The tool came in two versions. Besides a demo, a free version, there was also a commercial version of the tool. Its creator disappeared from the internet after some time. Tatya's last blog said that he wished the program had never been developed and that he hoped that it would only be used for non-malicious purposes. Tatya now probably works for a government institution, or the institution took care of him in some other way. The program shown in this presentation is simple and quite old. Professional tools for creating Trojan horses offer a much wider variety of features. And they're even more easy to use. This is why running an untrusted program is connected with risk. Various commercial reports indicate that a large portion, perhaps even 50%, of binary files shared over peer-to-peer networks and the like, and at least 10% of files shared on websites are modified and have Trojans or backdoors added to them. Let's explore how easily Trojans can be created. We'll use Beast 2.07. This is a tool dedicated to building Trojan horses that you can find on the internet. Trojan horses can be backdoors at the same time. Once they're run on a remote computer, an attacker can obtain full control over the computer. That's why Beast is perfect for the presentation. We'll be able to see step by step how an attack proceeds. Modern environments used to generate Trojans are today much richer. Their payload is usually more complicated than ejecting and inserting a CD drive of a remote machine, which is the goal we'll be trying to achieve. First, we need to build a server. Building a server involves setting up some basic options for a server. Since we'll be trying to connect to a remote computer, it's better to make it connect to us rather than the other way around. The advantage of reverse connection is that it eliminates one problem we mentioned earlier in the modules on computer networks. We deceive a firewall and/or an intrusion detection system by making a trusted, protected computer connect to us rather than vice versa. This is a reversal of a TCP session. We could also try to hide in a different process. We'll talk about concealing methods later. Our process will run directly in the host process the program will bind to. As you can see, we can hide under any process. We can also create a service that will be run automatically. If a victim terminates a program to which we've added a Trojan, the Trojan will still work. Submit the IP address of a computer that's to be connected to by an infected computer in the Notifications tab. This is not the address of our computer, but for example, the address of a computer we broke into yesterday. You can also request the program to send out an email to a submitted address. You can also be notified of a new victim through the instant messenger. We'll use the TCP protocol instead. You can specify in the Startup tab if your Trojan is to survive the termination of the program to which it's injected, or perhaps survive system restart. Over the next modules, we'll examine mechanisms for automatically running objects during a system launch. It'll turn out that registry keys and ActiveX controls are a good place for hiding. The threat of detection by an antivirus can be lowered by disabling one of over 300 antivirus scanners in the AVFW Kill tab. You can even disable them every 5 seconds just in case a user fights back and tries to run them again and again. Since XP Firewall was so popular several years ago, it has its own checkbox. You can disable it here without having to go through a list of 300 programs. Another option allows you to enable a keylogger. A keylogger is a program that monitors the sequences of pressed keys on a remote computer. If it's enabled, it's enough to wait for a user to log onto a website or run their mailer program to provide a password. It's not cached, of course, because the user protects the credentials. The server is built. Let's now save it. As you can see below, here's what our Trojan looks like. It's not highly probable that a user will decide to run it. If a program that's provided in this manner or found on a website is launched by a user, there's no use talking about system security anymore. Let's try to make the program more slight. We use Binder for this purpose. We need to select the Trojan and then select some random popular application. For example, the newest version of OpenOffice or a decoder which will convert files from X to Y. We also want our Trojan horse to have an icon from the selected file rather than no icon. Click on Bind Files and save the modified program, making it seem like the newest free version of the program. For example, exactfile-free version 3.exe. If you take a closer look at it, the program is a bit larger than the original software. I don't think anyone will notice this during the download. The program was copied to a remote computer for the purpose of this presentation. Ignore the social engineering aspect for a moment. Simply assume that somehow we've succeeded in persuading the user to download and run the program. Let's see what happens if the victim runs an integrity checker with the injected code. To get a better picture of the attack as it unfolds, we'll also show you what happens to the attacker's computer. A victim launches the program, and we'll start our server. In this way, we're controlling two machines. Alice and Cecil are the users logged onto the computers. Cecil will become the first target. We'll use the Go Beast button to connect to a selected computer. Thanks to Beast, you can now view the directories on the victim's hard disk. You can download and delete files, change file names, and run processes. You have control over the computer. You can also view the victim's configuration by looking at registry keys. You can also see the programs launched by the victim. The list includes our program. We'll simulate a scenario where the victim has, for example, opened a web browser. Using the Kill App button, you can terminate any program running on a remote computer. Besides these options, Beast offers many features added for entertainment. You can, for example, hide icons on the victim's desktop or eject and insert their CD drives. If your computer begins to act up after you download and run the newest version of a program, icons appear and disappear, the system clock appears and disappears, strange processes are run or terminated. This is not Windows' fault. The cause could be that the program you run contained an injected Trojan horse. Your system is now controlled by someone else. If you suspect that a given application can be the source of the problems and terminate it, you'll see that this doesn't bring about any changes. The Trojan is still running, and with that, we're ending the first presentation on Trojan horses. Trojan horse attacks, which could be mounted, for example, using Beast, are a result of users' ignorance. To tell you the truth, ignorance is perhaps the wrong word here. Many people are perfectly aware of the risks related to running files you come across on the internet, but think that since their computer doesn't contain any sensitive or important data, they can take the risk and download some program from the internet instead of buying it. If the price is advertisement pop-ups and warnings, it can be afforded. Many people seem to decide that their data can be sacrificed, and that it's worth it to take the risk that their computer can be used for attacking other systems. Running a program is more important for them. This approach is common, but still is perilous and the stakes are high.